In this video, we're going to make a revision on sets. First, the definitions of operations. A set is a well-defined group of objects. So, for example, while the set A is a well-defined group of objects, or, well, in this case, people, right? Because we're talking about students in our class wearing glasses. This is a good definition. While A is a set, B, although it's a group of objects, or in this case people, is not a set because it says some students, so we don't know. It is not well defined. What I'm saying is, in set A, everyone will make the same list for the students wearing glasses, whereas not everyone will come up with the same list of students if I say some students, right? So this is very important. And by the way, C is a well-defined group of objects too. Just because we don't have any member doesn't mean it's not a set. So students in our class with 3 eyes, this is a well-defined group here. So it is a set, but we call this as empty set, hopefully. And this is a well-defined group of objects, so this is a set too, and this is called as the universal set. I mean, from the context we can think about the biggest set possible, which is the students in our class, so it becomes the universal set. We can show sets on what we call as Venn diagrams. Venn diagrams gives us the opportunity to visualize what we're talking about when it comes to more than one set. So in a Venn diagram we have a rectangle, generally speaking, which represents the universal set, and then just because now we're talking about 2 sets A and B, we will have 2 circular diagrams for sets A and B, right? So this is called as a Venn diagram, and we can now define our operators like A union B means the combination of both sets. So it's going to be members in A or members in B, and I show this on a Venn diagram by shading both sets. So this is A union B, and whereas A intersection B means the common members of A and B. So I'm going to go like members in A and members in B. So the connectors are important. If it is or, then it's union. If it is and, so it's intersection. So I should shade the common region both in A and B. So this is A intersection B. We also have an operator that we call as negation. So this means the opposite of whatever the set is. So it's something like A prime, right? Negation of A. So this means everywhere but A. So you have to shade all these regions but the set A. So we're talking about the members that are not in A. Alright, so these are all the members that are not in A. Alright, so what if I write the intersection, for example? If I write A intersection B and I put a negation, right, this means exact opposite of A intersection B. So I should be shading all the regions but A intersection B. Right, so I leave this bit blank. So this is what I want to get out, to cut, right? So this A intersection B negation. And if I was to go with A union B, then I would shade, of course, the negation I'm talking about. Let me do this properly. So if I talk about the negation of A union B, then I'm talking about all the regions but A union B. So this is what I cut out from the shaded region, A union B. So this is going to be the negation. So this means members not in A and not in B, right? So let's see some examples. Given the sets below, where the universal set is positive integers less than 15, the set A is prime numbers and set B is integers bigger than 9, we are asked to list the members of A intersection B, A union B, and N union B prime, so the negation of A union B. Once you find A union B, it's easy, actually. But now let's look at this. The first thing I will do is to list the members of each set. So positive integers less than 15, it's going to be 1, 2, 3, up to 14 because it says less than 15. Set A is prime numbers, so it's going to be 2, 3, 5, 7, not 9, 11, and 13. These are the ones less than 15. Now, it says prime numbers only, and we can think of infinitely many primes, fine, but the universal set restricts us with the numbers less than 15. So I don't need to say prime numbers less than 15. If I read prime numbers, I look at the universal set, it says less than 15, so I stop here. And the same thing applies for B, right? It is going to be integers bigger than 9, so it's going to be 10, 11, 12, 13, and 14. That's it. Now, A intersection B, I'm looking for the members in common. So it is going to be 11, right, and 13, each of which I'm going to write once. 11 and 13. That's it. Next, it's A union B. I'm going to write all the elements in A and all the elements in B, but I'm not going to write the common elements twice. I'm going to write them once. So it's going to be the elements in A, 2, 3, 5, 7, not 9, but 10 because it's in B, 11, common member, 12 in B, 13 in both, and 14 in B. So this is going to be A union B. Now I prefer to write them in order, but it is okay if you don't. But the risk is that you may miss writing a member just because you're not going in order. So be careful with that. And the negation will be all the elements which are not in A union B. For example, 1. 2 is there, 3 is there, but 4 is not. 5 is there, 6 is not. 7 is there, but 8 and 9 are not. 10, 11, 12, 13, 14 are all there, so actually this is the negation. Now, if I was asked to put all these members on a Venn diagram, it would be like this. I would start with A intersection B, so it's going to be 11 and 13. Then A union B is all these sets together, so it's going to be 2, 3, 5, 7, and 11 and 13 are there in A, so I'm not going on. But 10, 11 is there, 12, 13, and 14. So I would have the members distributed like this, and the negation of A union B means all the elements not in A union B, so it's going to be 1, 4, 6, 8, and 9. This is how my Venn diagram would look like. If I was to write down the number of elements in each set, then it's not going to be like this. Rather, I'm going to write the number of elements. So A union B has 2 elements. Sorry, A intersection B has 2 elements, 2 members, right? A union B, so this reads as number of elements in A union B. It reads as like this: 1, 2, 3, 4, 5, 6, 9. So there are 9 elements, and the number of elements in A union B prime prime, well, that is 5, right? So this is what I was to put in. So I would write 2 here, and then A union B is 9. Now, of course, I can't just write 9 anywhere, but I have to go back and check the number of elements in A. So basically, I would ignore this bit, and I'm going to write the number of elements in A is, well, it's 2, 3, 5, 7, 11, and 13, so it's 6. And number of elements in B, number of members in B is numbers bigger than 9, so it's going to be 10, 11, 12, 13, 14, so it's going to be 5. Now, careful. The set A has 6 elements, of which 2 are in A intersection B only. So I have to write 4 here, because together they must make 6. And the same applies to B. It has 5 members, of which 2 is here in the intersection, so this must be 3. And as for the negation, we all know the number already, but 4 plus 2 is 6, 6 plus 3 is 9, so there are 14 members, so it must be 5 anyway. So this is how I would put the number of elements in each set. Now let's look at this example. In this one, I'm going to show all this information on a Venn diagram, right? And then according to the Venn diagram, I can answer any question I get. Now, 30 students in a class are offered 3 language courses: German, French, and Spanish. Now, 3 take all 3, so all courses. 7 take only French and German, 5 take only French and Spanish, 6 take only German and Spanish, 4 take only German, 3 take French only, and 1 take Spanish only. Now, to show this on a Venn diagram, first of all, I should have 3 circles, each of which will be languages. So it's going to be German, G for German, F for French, and S for Spanish, to no one's surprise. Now, all these sets will be in the universal set, right? So the universal set is 30 students in this class. Now, I will always start with the intersection of all. 3 take all 3. So there are 3 students who take all 3 courses. So I will always start from this part. 7 take French and German. French and German are here, so their intersection is here, right? So 7 students are in this region, of which 3 is already there. So this must be 4. So together they make 7. 5 take French and Spanish. French and Spanish. So it is this region we're talking about. Now, 5 students, of which 3 is already there. So it's going to be 2 more here. 6 take German and Spanish, right? So you're talking about this region. Okay, so 3 students are already there. It must be another 3, yeah? And 4 take German only. German only means this region, so I have to write here 4 students in this region only. And 3 take French only. 1 take Spanish only. Now, at this point, I have to make sure, or I have to check, let's say, whether those numbers add up to the number of students in the class, which is the number of elements in universal set. So it is 4 plus 4, 8, 8 plus 3, 11, 13, 16, 19, and 20. Now, the students who are taking any course adds up to 20. So this means there are 10 students in this class who doesn't take any course at all. Now, if the question gives you that all students take at least 1 course, then you can expect this number to be 0, because all the students will be in any set, alright? But here it doesn't say that, so we have to make sure that, these add up to 30. If not, I have to complete it to 30. So this means 10 students do not take any language courses. Now, the questions could be, the number of students who do not take any course at all. Now, this means we're talking about these students, so you go with, 10 for this. Number of students who do not take German, so this means we're talking about negation of German, so I should be considering these numbers to add, right? It's going 3 plus 2, 5, 6, and 16 altogether. So the second one, the answer will be 16. Now, let me just clear this mess up a little bit. Now, let me write, this is 10, this is 16, these are the answers. Right, so the third question says, number of students who do not take French and Spanish. Well, the students take French and Spanish here, right? So we're talking about students who do not take French and Spanish. So there are 4 students who are taking German only, good. And there are students here who do not take any course at all, so I have to consider these while answering it. So the answer must be 14. So the thing is, when I have my Venn diagram, I'm all good. I can answer any question that could be asked. Of course, in such questions, the first thing would be complete the Venn diagram, of which they would give a blank one in the question. So you would fill in with the numbers, right? And then you will answer the questions posed in the question, right? I think it's pretty much it. I mean, if you know about the operators, if you know how to draw Venn diagrams, if you know how to list elements, then you'll be pretty much okay answering any sort of set questions. Thank you.